Hello students, I am Dinesh Khanna, HOD Science, Srcc, Janak, Puri. I will be teaching you chemistry, physics as well as bio. To start with, we'll start with the chapter Electricity and its effects. Electricity has been a new topic for you as you have not done it in your previous classes. So I'll go very slow so that you understand each and every concept of electricity. Starting with the chapter Static Electricity. Static electricity. What is static electricity? The electricity inherent in an object, present inside an object, is called static electricity. That is, the electricity that does not move is called static electricity. And the electricity that has a property of movement, that is called current electricity. Is that clear? Now, static electricity. For example, when you rub a glass rod, this is a glass rod with silk. The glass rod acquires a positive charge and the silk acquires a negative charge. What is it due to? This happens because when you rub a glass rod with silk, the electrons, what are electrons? The negatively charged particles, subatomic particles. The electrons, they flow from the glass rod to the silk cloth, due to which the glass rod is negative charge deficient, due to which it becomes positively charged while the silk acquires a negative charge. This is example number 1. Example number 2. If you rub an ebonite rod with wool, in such a case, the ebonite rod acquires a negative charge while the wool acquires a positive charge. Why does it happen? This happens because on rubbing, the electrons flow from the wool to the ebonite rod. The wool becomes electron deficient and is hence positively charged, while the ebonite rod gains electrons, due to which it becomes negatively charged. This is what static electricity is all about. Now, moving on to the next topic, that is potential. What is potential or electrostatic potential? Please try to understand the basic concept of electrostatic potential. You have heard it for the very first time. Electrostatic potential. Electrostatic potential. Electrostatic potential. Electrostatic potential at a point, supposing this is the point, can be defined as the work done in moving a unit positive charge. What do you mean by the word unit positive charge? Plus 1 charge. A charge of magnitude plus 1. A unit positive charge from infinity to this point. You understand? It is the work done. The work that has to be done in moving a unit positive charge plus 1 charge from infinity to point A. So how will you define the electrostatic potential at point A? Electrostatic potential at point A can be defined as the work done in moving a unit positive charge from infinity to that point A. What will be electrostatic potential at point B? It can be defined as the work done in moving a unit positive charge to point B, in the same way to point C, D, E and F. It is denoted by, electrostatic potential is denoted by V. V is equal to W upon Q. where W is the work done. W is the work done while Q is the charge flowing. V is the electrostatic potential is equal to work done upon charge. You might have done in your 9th class, what is the unit of work? The unit of work is joule and the unit of charge is coulomb. The unit of charge is coulomb. The SI unit of electrostatic potential is volt. So what is 1 volt equal to? 1 volt is equal to 1 joule upon 1 coulomb. 1 joule upon 1 coulomb. Have you understood what is electrostatic potential? Can 2 points have equal potentials? No. These 2 points cannot have, because work done in moving a unit positive charge from infinity to 2 different points will be different. Due to the difference in the work done in moving this unit charge to 2 different points, the potential at 2 different points will be different. So this is electrostatic potential with a unit of volt. The next topic is potential difference. The next topic is potential difference. Potential difference. Potential difference is always between 2 points. For example, what will be the potential difference between A and B? It can be defined as the work done in moving a unit positive charge from A to B. From A to B. What is potential difference? Potential difference between 2 points can be defined as the work done in moving a unit positive charge from one point to the other. It is also denoted by V. This is potential difference is equal to work done upon charge, or V is equal to W upon Q. Unit of V, the potential difference is volt. So 1 volt is equal to 1 joule upon 1 coulomb. 1 joule upon 1 coulomb. What is potential difference then? Potential difference has always to be defined, that is between 2 points. Potential difference between 2 points can be defined as the work done in moving a unit positive charge. Unit positive means 1 coulomb charge from one point to the other. Now, to the definition of 1 volt. To the definition of 1 volt. How can you define 1 volt? 1 volt. 1 volt is equal to 1 joule upon 1 coulomb. How can you define 1 volt? To define 1 volt, you will say 1 volt is the potential difference between 2 points. Between 2 points, when 1 joule of work, 1 joule of work has to be done to move 1 coulomb charge from one point to the other. Is that clear? Make the other quantities also 1. So how do you define 1 volt? 1 volt is the potential difference between 2 points when 1 joule of work has to be done to move 1 coulomb of charge from one point to the other. Is that clear? So this is what potential difference is. Actually, we call it voltage. You might have heard of the word voltage in your households. Voltage is potential difference. What is the significance of potential difference? For the current to flow between 2 points, there should be a difference in potential between 2 points. That is called the voltage. So if there will be voltage, the current will flow. Otherwise, if the 2 points are at the same potential, no current will flow. In the same way, as the water flows from a higher altitude to the lower altitude, because there is a difference of height between the 2 points. If the 2 points have same height, then water will not flow spontaneously. Is that clear? So, have you understood the definition of 1 volt potential difference? Now moving on to the instrument that is used to measure potential difference. The instrument used is a voltmeter. A voltmeter is an instrument which is used to which is used to know the potential difference. This is voltmeter. It is always connected in parallel. I'll tell you what parallel is in the further classes. Is that clear? Moving on to the numericals now on potential difference. You have just to do the numericals which I'll do in the class and the numericals which are present in your study material. No other books, nothing. Now, for example, you get a numerical, calculate the potential difference between 2 points. If 2.5 millijoule of work has to be done to move 1 microcoulomb charge from one point to the other. Now, first of all, you should know what is milli. 1 milli is equal to 10 raised to power minus 3. 1 micro, it is written like this also. 1 micro is equal to 10 raised to power minus 6. 1 nano is equal to 10 raised to power minus 9. Okay? Now to the question. Before solving the numerical as a whole, you have to write the formula. Because in boards, you will be getting marks for writing the formula, putting in the values, and then calculating the sum. Now, the formula will be V is equal to W upon Q. What is given to you? Work. W is equal to 2.5 millijoules is equal to 2.5 into 10 raised to power minus 3 joules. Okay. Second is charge. Q is equal to 1 microcoulomb. That is equal to 1 into 10 raised to power minus 6 coulombs. Put in the values. The V is equal to W. 2.5 into 10 raised to power minus 3 upon 1 into 10 raised to power minus 6. What does it come out to be? 2.5 into 10 raised to power minus 3 into 10 raised to power 6 is equal to 2500 volts. 2500 volts is the potential difference between 2 points. Do you understand? When you want to solve a numerical in your board exams, write the values, convert into required SI units, then put on these values in the formula, then calculate the things. Is that clear? Now, moving on to the numerical number 2. Calculate the work done in moving 6.5 millicoulomb charge from one point to the other. Potential difference between 2 points is 26 millivolts. 26 millivolts. What is given to you? Charge of 6.5 millicoulombs. So that means Q is 6.5 into 10 raised to power minus 3 coulombs. What is the voltage given to you? V is equal to 26 into 10 raised to power minus 3 millivolts, or this is volts. So what is V equal to? W by Q, or W will be equal to V into Q, will be equal to V 26 into 10 raised to power minus 3 into 6.5 into 10 raised to 1 minus 3. Is that clear? Multiply this to get the answer in joules. So that is all about what potential difference is all about. Is that clear? So W is equal to V into Q, V into Q. The main thing is you have to convert these millis and micros into the SI units, that is joules, coulombs or volts, etc. Is that clear? Now, moving on to the second topic. You'll get more and more questions in your study material. You'll do it from there, have the problems. Okay? We are now moving on to current. What is current? Charge flowing through a point per unit time. Charge flowing through a point per unit time is called the current. So what is current equal to? Current is equal to charge upon time. That is charge flowing upon time taken. It is denoted by I. So what is I equal to? Charge flowing Q divided by time T, where Q is the charge and T is the time. How do you define current then? It can be defined as charge flowing through a point per unit time. Its SI unit is ampere. What is the unit of current? Ampere. Now what is the SI unit of Q? That is charge. We have already done it. Charges in coulombs. And time, the SI unit is second. SI unit is second. So what will be 1 ampere equal to? 1 ampere will be equal to 1 coulomb upon 1 second. 1 coulomb upon 1 second, because SI unit of time is second. Okay? So this is what current is all about. How do you define 1 ampere? You will definitely get a definition of any of the units of potential difference, resistance, current. How do you define 1 ampere? Try to speak it out to yourself. What will be the definition of 1 ampere? To define this 1 ampere, you will have to take 1 coulomb and 1 second. So what is 1 ampere? It can be defined as the current flowing through a conductor. Current flowing through a conductor if a charge of 1 coulomb flows through the conductor in 1 second. Current flowing through a conductor is said to be 1 ampere if a charge of 1 coulomb flows through the conductor in 1 second. It is measured by an instrument called ammeter. This is measured by an instrument called ammeter. This is connected in series to this. In the circuit, we will tell you what series is all about in the next class. So this is what current is. Current is charge flowing per unit time. Charge upon time, unit of charge is coulomb, that of time is second. Now, if in a numerical, if you get the charge in millicoulombs, microcoulombs, first of all, you will have to convert it into coulombs. The time definitely has to be converted into seconds. If it is given in hours, multiply by 3600 to get it in seconds, or if it is given in minutes, multiply it by 60 to get it in seconds. Moving on to the first numerical from current. First numerical from current. A charge of 3000 coulombs flows through a conductor in 10 minutes. Mind you, this is minutes. Underline the things. When you have to change the units, underline the question. 10 minutes. Calculate the current flowing through the conductor. Current flowing through the conductor. Now, what is given to you? 3000 coulombs. So Q is 3000 coulombs. Time is 10 minutes is equal to 10 into 60 is equal to 600 seconds. The charge is actually given in coulombs, you don't need to convert it. 10 minutes is 600 seconds. So what will be I equal to Q by T, or I will be equal to 3000 upon 600. That is equal to 5 amperes. The answer is 5 amperes. In the boards, you will get a 3 marker from this. How will the marks be divided in this question? 1 mark will be there for writing what is given to you. The second mark will be for writing the formula, and the third for putting in the values and getting the result. So this is that. You cannot do it as such to write it here and then you solve it like this directly. No, you will not be getting the marks in boards. Please find it. Okay. So this is the numerical on current. To a very important board question now that appears in the board very often. Moving on to question number 2, that is a board question. I'll write it BQ here for board questions. This is a bit tough. Tough means a complex type of a question as compared to these simple questions we have been doing. Now, a current of 3 amperes flows through a conductor for 1 hour. 3 amperes for 1 hour. Calculate. Number 1, total charge flowing through the conductor. And number 2, number of electrons flowing through the conductor. First of all, the first part you have already done in the last question, total charge. Total charge can be calculated. If I and T is given, you can calculate charge. But number of electrons flowing through the conductor, that is the main thing. Here, you will be given charge on 1 electron will be given to you is equal to 1.6 into 10 raised to power minus 19 coulombs. This is a charge on 1 electron. 1.6 into 10 raised to power minus 19 coulombs. Now, what is I equal to? Q by T. I is given to you. I is given to you 3 amperes. And T is given to you 1 hour. 1 hour is equal to 1 into 3600 seconds. That is equal to 3600 seconds. Okay. Putting in the values, we'll first calculate the total charge. We'll calculate the total charge. Now, what will be Q equal to? I into T. Or Q will be equal to I into T, 3 into 3600. That comes out to be 10,800 coulombs. This is what the total charge is. Now you should remember one formula. This is the total charge flowing. Now total charge is equal to N into Q, where N is the number of electrons and Q is the charge on, or you can write N into E. E is the charge on 1 electron. N into E, number of electrons, into charge on 1 electron. Putting the values here, total charge was 10,800 is equal to number of electrons into charge on 1 electron. 1.6 into 10 raised to power minus 19. So what does N come out to be? N will be equal to 10800 divided by 1.6 into 10 raised to power minus 19. ठीक है, 19 goes up. 10800 into 10 raised to power 19 upon 16 into 10 from here. Okay, 1, 2, 3. That comes out to 108 into 10 raised to power 22 divided by 16. Six point seven five into 10 raised to power 22 electrons is the answer. Do you understand? If you get I, if you are given I and T, convert it into total charge where Q is equal to I into T. And then Q will be the total charge. Now Q is equal to N into E, where N is the number of electrons flowing, E is the charge on the electron. You will be given the charge on the electron in the question paper, but you can still remember it as 1.6 into 10 raised to power minus 19 units of negative charge is present on an electron. Is that clear? So this is how to get. This is a very important question. Very important question. You can do other questions like this also. Okay. Moving on to another complex question. Another complex question relating to potential difference, current and charge. So that will combine both the formulae we have done in this class. The first one, that is V is equal to W by Q, and then Q is equal to I into T. Okay. Let us start. Potential difference between 2 points is 300 volts. 300 volts. If a work of 20 joules has to be done in moving a particular charge through these points, or you can say between these points, in 10 minutes, calculate number 1, charge flowing, number 2, current flowing. Potential difference is given to you, work done is given to you from the difference of potential difference and current. Use this formula to get what? To get the charge. From the charge you can calculate the current. Now, what is this? V is equal to W by Q. What is given to you? First of all, right? V is equal to 300 volts. W is equal to 20 joules. 300 volts, 20 joules, time is 10 minutes is equal to 10 into 60 seconds. 600 seconds. Now first of all calculate charge flowing Q. So Q will be equal to W by V is equal to 20 upon 300. This is coulombs. Charge has come out to be 20 by 300, 2 by 30 coulombs. Coulombs. Now what is current? Current is equal to Q by T, or current will be equal to Q you have calculated to be 2 by 30. What is the time here? 600 seconds divided by 600. If 15 twos are, I comes out to be 1 by 9000 amperes. So that is all about current. Students, in the next class, we'll be moving on to Ohm's law. Relationship between potential difference, and current. A direct relationship between potential difference and current. Will be doing the curves on Ohm's law. Please revise these things. Okay? Bring the video to the pause mode. Learn these things. Learn the definitions. Do the numericals. Try some more numericals from the NCERT if you have it. Okay? Otherwise, I'll be sending you the study material in a few days. Okay? Remain safe. Be happy. Enjoy yourselves. But study hard. Okay? Thank you very much.